Hi Math 3 students. So today we are going to do kind of a summary of what we've learned about rational functions. So it's going to be a lot of information, so feel free to pause the video whenever you need to, and make sure you take good notes. All right, so first we're going to talk about graphing and analyzing rational functions. So this is finding asymptotes, finding intercepts, finding holes, all that good stuff. So the first thing you always have to remember is when you're trying to analyze rational functions, you have to factor the top and bottom if you can. That should be kind of your first goal here. So I have some examples. So our first example is x squared plus 5x all over x squared plus 5x plus 6. So we need to make sure that we factor everything. So on the top here, we've got two terms. We can take out a GCF there. All right. So we can take an x out, and we get x plus 5 on top. And then on the bottom, we've got a trinomial. So we need to figure out what multiplies to give us a 6 and adds to give us a 5. That is going to be x plus 3 and x plus 2. So for this first example, that is how you would factor that. It's going to make things a lot easier down the line. Now we have another example. All right, I look here and I actually can't factor the top at all. There's nothing I can factor out of an x plus 8, but I can factor the bottom. The bottom follows the difference of squares factoring pattern, which is if you have a squared minus b squared, you get a plus b and a minus b. It's a common factoring pattern. So if we wanted to factor this x squared minus 64, we get x plus 8 and x minus 8. So that is how you factor, all right? So now it says to find the y-intercepts, plug in for 0. All right, so let's go ahead. Let's find the y-intercepts for this first example. This will be our example 1. So to find the y-intercept, we have to plug in a 0 for x. Now, you could either plug into the non-factored form, or you could plug into the factored form. I'm going to plug into the not factored form. So we get 0 squared plus 5 times 0 all over 0 squared plus 5 times 0 plus 6. All right. In there, we end up getting 0 over 6, which gives us 0. So our y-intercept is actually going to be 0, 0. All right, so now let's go ahead. Let's try our second example here. Again, to find the y-intercept, you're going to plug in a 0 for x. So I'm going to plug a 0 in here for my first example. So let's do 0 plus 8 all over 0 squared minus 64. Which is going to give us 8 over negative 64, which will give us negative 1/8. So our y-intercept for this one is going to be 0, negative 1/8. So again, to find the y-intercept, you plug in for 0. You plug in 0 for x, sorry. All right, so let's go ahead and try the next one. It says to find the holes, see if any factors cancel on the top and bottom. If something is a hole, it is neither an x-intercept or a vertical asymptote. All right, so let's go ahead and see if we can find a hole. So if we look at this first guy, we have x plus 5 all over x plus 3 and x plus 2. All right, so essentially to find a hole, you need something that's going to cancel on the top and the bottom. There is nothing that's going to cancel here. So example 1 actually has no holes. All right. Then if we look at example 2, we look and we see that we've got x plus 8 on the top and x minus 8 on the bottom, x plus 8 on the bottom. So we're trying to see if we can cancel something on the top and the bottom. We can. We can cancel the x plus 8. So that tells us that we're going to have a hole. Actually, I guess you take the factor that you can cancel and you would set that equal to 0. You're going to have a hole at x equals negative 8. All right. So you may not always have a hole, but you might. If your factors cancel on the top and the bottom, you've got yourself a hole. right, next one. It says to find the x-intercepts, set the top equal to 0. All right, and one thing I want to point out is it says that if something is a hole, it is neither an x-intercept or a vertical asymptote. And the reason for that is when there's a hole, that means that it's not in the domain. You're not allowed to plug in a -8 into this function because you're going to end up dividing by 0, which is bad. So if we look here, it says to find the x-intercept, set the top equal to 0. So let's go ahead and look. We're going to take our first example, and you're definitely going to want to use the factored form. So really for all of these, I guess I should have said we're going to use factored for this. We got to use factored for this. Whoops, can't write. All right, so we're going to use the factored form, and we've got x plus 5 all over x plus 3, x plus 2. So, of course, we need to set the top equal to 0, which we get x times x plus 5 equals 0. Since it's already factored, you just set each of the factors equal to 0. And you get x equals 0 and x equals -5. So, our x-intercepts are going to be 0, 0. And -5, 0. All right, so now let's go ahead and we can try out our example 2. So we look and we've got our x plus 8 all over x minus 8, x plus 8. Well, if we set the top equal to 0, we get x plus 8 equals 0, x equals -8. However, right, x equals 8 was a hole up here, right? That means that it's not in the domain. So that means that there's actually going to be no x-intercepts. All right, no x-intercepts here. If there had been another factor on top, we might have had an x-intercept, but since our only 0 was not in the domain, we've got no x-intercepts. All right, so then it says to find the vertical asymptote, set the bottom equal to 0. So again, let's go ahead and do our example 1. We've got x plus 5, over x plus 3, x plus 2. So we're going to set the bottom equal to 0. So we get x plus 3 equals 0. Or actually here, I should do the whole thing. X plus 3, x plus 2 equals 0. So you end up with x plus 3 equals 0 and x plus 2 equals 0, which is going to give you x equals -3 and x equals -2. And those are your 2 asymptotes. Now again, you have to double check, right? Neither of these were holes, so you're good to go. If they had been holes, then they would not be vertical asymptotes. So let's go ahead and do example 2. Got x plus 8 all over x minus 1. Oh, I'm sorry, x minus 8. X plus 8. So again, we have to set the bottom equal to 0, so we get x minus 8 equals... Oh my goodness, x minus 8 times x plus 8 equals 0. We get x minus 8 equals 0. We get x equals 8. And x plus 8 equals 0. We get x equals -8. So again, we run into a problem that there is a hole here at -8. So this one is not a vertical asymptote. The only vertical asymptote you have is x equals 8. So I would maybe star this. If something is a hole, it is neither an x-intercept or an asymptote. It's a hole. Or, I'm sorry, an x-intercept or a vertical asymptote. It's a hole. All right, we're making progress. So now it says if the degree of a denominator is larger than... Oh, for this one, we're finding the horizontal asymptote. Okay? So I already have an example put in here, so we'll analyze a different function. It says, for finding the horizontal asymptote, you kind of got to figure out the ratio of the degrees. So if the degree on the bottom, or in the denominator, is larger than the degree in the numerator, or on the top, your horizontal asymptote is automatically y equals 0. Automatically. So you don't got to do any work, you find it that way. Next, if the degree on the denominator is equal to the degree in the numerator. So if we look here, right, we've got a second degree on top, second degree on the bottom. Those are equal. You take the ratio of the leading coefficients. So in this case, it would be y equals 5/3. All right, then we've got that slant asymptote situation. So if the degree in the denominator is less than the degree of the numerator, so that's when your degree on top is bigger than your degree on the bottom. Here it's 2/1. All right, this is kind of that improper situation. That's when you have to do some division. It says, when this is the case, there is no horizontal asymptote. You have to do long division. The answer is the equation of your slant asymptote. All right, so both of these asymptotes that we talked about, they go horizontally just like this. All right, however, when you get a slant asymptote, it could go like this, it could go like this. You're essentially going to get an equation of a line. And actually, things can get really crazy if you get tougher ones. You can even get asymptotes that look like parabolas. It's real crazy. But in this case, we're just going to get a slant asymptote that looks like a line. But we have to go ahead and do the division for that. All right. So I would probably highlight do long division. If this is the case, you got to do that. So we'll go ahead and we will do some division. So we got x plus 2 divided by x squared plus 5x plus 7. And we go ahead, we say, okay, how many times does this x go into x squared? We get x. We have to go ahead and multiply. So we get x squared plus 2x. Then you got to change your signs. You get minus, minus. You get 3x. And you're going to have to go ahead and bring your 7 down. And you see, okay, how many times does x go into 3x? That's going to be 3 times. So you go ahead and multiply. You get 3x and you get 6. And then you change your signs. So your remainder here is going to be 1. So you end up with x plus 3 plus remainder of 1 over x plus 2. Your slant asymptote is going to be y equals x plus 3. It's basically your answer. All right, so this would be your horizontal asymptote. You don't really need to worry too much about the remainder. It's just going to be whatever your answer is. It's going to be y equals that. All right, cool. So now let's go ahead. Oh, and also I guess I would kind of say, the last step here would be to graph on Desmos. That would help you get a idea of the shape. So now we're going to go ahead and review adding and subtracting rational functions. All right, so notice the directions here say factor, then get a common denominator. So notice how there's a ton of factoring on this. So let's go ahead. We'll factor this. We can't factor really anything on the top or on the bottom of this first one, so we'll leave it like that. And again, can't factor anything on the top, but we can factor the bottom here. This is that difference of squares again, right? So for this one, it's going to follow that factoring pattern where we get x plus 4 and x minus 4. So now looking, we have to work on getting our common denominator. So this second guy has x plus 4, x minus 4, and the first guy only has x plus 4. So we're going to have to go ahead and multiply him by an x minus 4 over x minus 4. All right, so when you do that, you end up with, well, actually, I should say, too, you need to distribute, right? On top, you either need to FOIL or distribute or do whatever you need to do to multiply what's being multiplied on the top. So we end up with 3x minus 12 all over, and then our common denominator of x plus 4, x minus 4. And then we can go ahead and just rewrite our second one here. It was already good to go, which is 3x minus 4 all over x plus 4, x minus 4. So now, all you have to do is add the top, right? We've got our common denominator, so all you need to do is add the things in the numerator. So we can combine like terms. We get 3x, and 3x is going to give us a 6x. And then we've got a negative 12 and a negative 4, which is going to give us a negative 16. And that's going to be all over x plus 4 and x minus 4. And that is your solution to that one. So now let's go ahead and try subtracting. So again, it's pretty much the same thing. You have to make sure that you first factor everything and then work on getting a common denominator. So here we can't factor anything on the top. We got x plus 2. On the bottom we have a 6 and a 42. So I'm looking, I could probably take a 6 out of there. So let's factor a 6 out and we get x minus 7. Then we've got an x minus 3 on top. And then I look on the bottom, I can take a 5 out. I get x minus 7 as well. So we're actually super close here to getting a common denominator. They both have an x minus 7. So essentially I have to work on getting the 6 and the 5 there. So this guy is missing a 5, so we're going to multiply him by 5 over 5. So we're going to do 5 over 5. And again, we have to make sure that we distribute. All right. So we're going to have to distribute the 5 to each of these terms. Even if it's backwards, let's see, x plus 2 times 5 is the same as 5 times x plus 2. So we have to distribute. All right. So you end up with 5x plus 10 all over, and then the 6 times 5 is going to give us a 30. So we get x minus 7. Then we'll go ahead and look at this next one. He is missing a 6. So we're going to go ahead and multiply him by 6. We got x minus 3 times 5, x minus 7. We're going to multiply that by 6 over 6. And again, we have to make sure that we do our distribution there. And don't forget your negative sign. Bring that down. So we'll put our negative sign there. And we end up with 6x minus 18 all over 30x. Oh, sorry. Yeah, 30. My apologies. Times x minus 7. So now, kind of a trick with subtraction, and this is going to be where a lot of people mess up. You have to make sure that you distribute this negative to each term. All right. So on the top, we end up with 5x plus 10 minus 6x plus 18 all over our common denominator, which is 30x minus 7. You can combine like terms. These guys give you a negative x. These guys give you a 28. So you get negative x plus 28 all over 30 times x minus 7 on the bottom. So that was adding and subtracting rational functions. So let's go ahead and do some multiplying and dividing. So it says we have to factor. Again, notice factor and cancel diagonally or up and down. Do not cancel side to side. So let's go ahead. We got a 4x on top. Can't really do much with that, but we can factor this bottom. I can take an 8 out of there. So I get x plus 1. Then on top, I'm going to see what I can do there. I need to figure out what multiplies to give me a 7 and adds to give me an 8. It's going to be x plus 7. X plus 1, and then on the bottom I still got 8x cubed. All right, so now we've factored and we have to cancel diagonally or up and down, not side to side. So let's look. I can definitely cancel this x plus 1. Now I want to show you where you can't cancel. I see 2 8s. You cannot cancel those. Why can I not cancel those 8s? Because you cannot cancel side to side. All right. So I just wanted to point that out. What you can do, though, is we could cancel this 4 with this 8. 4 over 8 gives us 1/2. So that's going to give us a 1 over 2. And then this x can cancel with this x cubed, and we get an x squared down here. All right. So on the top, I am left with a 1 times x plus 7, which we would just leave as x plus 7. And then on the bottom, I am left with a 2 times 8 times x squared, which is going to give me a 16x squared. All right, so again, you have to make sure that just like before, you factor everything. Then you have to cancel out what you can cancel. All right, now we've got dividing. So again, factoring, our favorite thing to do. We have to go ahead and factor this. So I got to figure out what multiplies to give me a -8 and adds to give me a -2. That is going to be m. Let's see, m, how about m minus 4? M plus 2. That's going to give us our -8. And then on the bottom, I can take a GCF out, I can take an 8 out, and I get m plus 6. Now, with dividing, don't forget to flip. All right, you have to put the numerator in the denominator in the numerator. Don't forget to do that. So we'll go ahead. Oh, and you have to, I should say, don't forget to flip and switch. Right, you have to switch the division to a multiplication sign. So we'll go ahead, we'll do this guy first because we're going to put him on top. We have to figure out what multiplies to give us a 12, adds to give us a 7. That is going to be m plus 4 and m plus 3. So then we can go ahead. We can take a 2 out of here. So we get, oh man, I was looking, I'm like, something's funky here. Hopefully you guys noticed my error. This should have been an m plus 3 on the bottom, not an m plus 6, right? 8 times 3 gives you 24, not 8 times 6. Oopsies. I'm glad I caught that because I was looking, I was like, something ain't right. Okay, so anyhow, we have to factor this guy. We're going to take a 2 out. We get m minus 4. So now we've factored everything. We got to start canceling. So m minus 4 and m minus 4 will cancel. M plus 3 and m plus 3 will cancel. So we are going to be left with a m plus 2 on the top, and m plus 4 on the top, and then we get a 16 on the bottom, which is the 8 times 2. So that is that. All right, we are on our last page here. You guys are doing good. I know this is tough. Now we're going to go ahead and do solving rational equations. So I guess the directions for this would be to, you guessed it, factor, and you need to get a common denominator. And then once you get that common denominator, you can just drop it or get rid of it. So once you have a common denominator across the bottom, you can just like get rid of denominator. All right. So let's go ahead. Let's do a factor in here. So we got v minus 6 on the top. Can't do much with that. And then on the bottom, it's looking like I can take a, I'm going to leave a little bit of space here. I can take a greatest common factor of 2 out. And then let's see, it'd be what, plus 2 minus 1. So we're going to get 2 times v plus 2. V minus 1, how did I get that? I was like, well, what's going to multiply to give me a -2? Add to give me a 1. So we're going to have a 2, v plus 2, v minus 1. So then we can go ahead, we look over here. Can't do much with the v. I'm going to take a 2 out. I get v minus 1 on the bottom. And then over here, you literally can't factor anything from 1 over 2. So it's looking like this is going to be our common denominator, 2, v plus 2, v minus 1. So we got to figure out what is missing on all of the other ones. So when I'm looking here, this guy is missing a v plus 2. So I'm going to multiply him out. So we'll multiply that by v plus 2 all over v plus 2. And at this point, you should go ahead and do the distribution. That's something you're going to want to do. So we can go ahead and simplify this. right? We're going to distribute this v. We get v squared plus 2v all over 2 times v minus 1 times v plus 2. So we've got our common denominator. Yay! And then looking at this guy, he's missing a lot, right? He's missing v plus 2 and v minus 1. So we've got 1 over 2 times v plus 2, v minus 1, v plus 2, v minus 1. All right, and what you get there, we're going to have to multiply that top out or FOIL it, right? So you end up, and since it's a 1, you can kind of just ignore it, right? Multiplying by 1. So you should end up with v squared minus v plus 2v minus 2. And then this is all over 2 times v plus 2 times v minus 1. And then we can actually go ahead, excuse me, and combine some like terms here. So we get v squared plus v minus 2 all over 2 times v plus 2, v minus 1. So now, that's a lot of work. This guy is going to get replaced by this guy. And this guy is going to get replaced by this guy. So let's go ahead and rewrite that. Super fun. So we get v minus 6 all over our 2v plus 2, v minus 1. Minus, and then we've got v squared plus 2v all over 2, v plus 2, v minus 1, equals, and then our green guy, which is v squared, plus v minus 2 all over 2 v plus 2 v minus 1. So now, also one thing, this should have been a plus. I accidentally made it a subtraction sign. But now if we look, we do have a common denominator across the board. So we could go ahead and drop out that common denominator and solve. So we got v minus 6 plus v squared plus 2v equals v squared plus v minus 2. All right, so we can combine like terms here on the left-hand side. So we end up with v squared plus 2v. Oh, I'm sorry, no. V squared plus 3v minus 6 equals v squared plus v minus 2. So now let's go ahead and kind of start combining like terms and getting some things on the same side here. So we could do minus v squared. And what happens is both of the v squareds cancel out, which is kind of nice. And then we're going to go ahead. We end up with 3v minus 6 equals v minus 2. Let's do minus v. You get 2v minus 6 equals negative 2. Bring the 6 over. And you should end up with 2v equals 4. All right, and then you divide by 2, and you get v equals 2. All right, and again, you got to kind of check for those extraneous solutions. So you're going to take your, I'm going to make this a little bit smaller. I wrote quite large there. Oops. You could go ahead and take that common denominator, which is 2v plus 2, v minus 1, set it equal to 0. You can't make 2 equal to 0, so that doesn't work. V plus 2 equals, v plus 2 equals 0 and v minus 1 equals 0. You get v equals negative 2 and v equals 1. So those are essentially the values that v cannot be. And our solution was v equals 2, right? So that solution does check out. All right. So I got one last one here, guys. Hang in there with me. You're doing a good job. This is a good summary of the whole unit here. So I know this is tough, but I think this is a really good review for you guys. So we got one more. Again, we got to try and get a common denominator. So we're looking. This guy's got a 4K. This guy's got a K. So, and this guy in the middle doesn't have anything. So our common denominator is going to be 4K. So what we're going to want to do there is... Oh, hold on. sorry, we have to try and get that common denominator. So that first guy there is missing a 4. So we're going to go ahead and multiply him by 4. So we got k plus 1 over k. And we're going to multiply him by 4 over 4. So again, we want to, of course, distribute. And we end up with 4k plus 4 all over 4k. This guy is like 1 over 1. So he needs both he needs both the 4 and the k. So we're going to multiply him by 4k over 4k. And you end up with 4k over 4k. And this last guy, fortunately, already has the common denominator of 4k, so you're good to go. So you just do minus k squared minus 3k minus 4 all over 4k. So now you've got that common denominator. Way to go. So what you can do is you can drop out that common denominator. And keep in mind, this is a subtraction, not an addition here. So what you have to do is you have to distribute this negative sign to each of these terms. So we end up with 4k plus 4 equals 4k minus k squared minus 3k. Oh, I'm sorry, plus 3k plus 4, right? Because you have to distribute that negative. I almost forgot to distribute the negative myself. All right, so now let's go ahead and try and start combining some like terms here. So I can, we'll combine like terms all on this side. So we end up with negative k squared plus 7k plus 4. And this is going to be a quadratic, so you're going to want to bring all these terms over here. So we'll do plus k squared plus k squared. So I get k squared plus 4k plus 4 equals 7k plus 4. And then we can bring the 7k over. We get k squared minus 3k plus 4 equals 4. Bring the 4 over. And we get k squared minus 3k equals 0. So at this point, we could factor. And we get k times k minus 3 equals 0. So we get k equals 0 and k equals, I should say k minus 3 equals 0, which gives us k equals 3. All right, but now we have to go ahead and check for extraneous solutions, right? So we're going to take our bottom, 4k, and set it equal to 0. We divide by 4, we get k equals 0. Ooh, so that tells us that k cannot equal 0. So one of these solutions is bad. We got to cross off that k equals 0. The only good solution here is k equals 3.